Welcome to Module 3 in PCC's 288M, and this particular module we're going to talk about Advanced DNS. In our last module we covered Basic DNS. Let's see what we're going to talk about. We're going to talk about the DNS zones storage, policies, and security. So we go a couple of steps beyond just basic configuration. So let's talk about managing DNS zones. And if you have a network that changes IP addresses and hosts coming online, going offline a lot, then you may need to change your zone transfer settings. You can also configure your zone scavenging to delete stale resource records. So when the resource records become out of date, they automatically update. Zone delegation is when you transfer authority for a subdomain to a new zone. So for instance, when a subdomain has been delegated to a zone on another server, then that DNS server hosting the parent zone maintains only a name server record. And that points back to the DNS server hosting the delegated zone. So when the DNS server of the parent receives a query, it refers the query to the DNS server hosting the subdomain. It automatically delegated zones on domain controllers. So of course when you install a domain controller on your DCO1, DCO2, you automatically have DNS installed. So every Windows domain zone has this _ MSDCS subdomain. If you delete that, then you'll no longer have replication between Active Directory DNS, and then that could cause all kinds of problems when your clients try to go resolve names to IP addresses. In the forest root domain, the subdomain is delegated to a new zone on the same server. So it's automatically created in any type of Active Directory domain controller. On non-Active Directory domain controllers or in a non-AD zone on a domain controller, you won't see that _ MSDCS. So this is what it looks like. You have the MSDCS at the top and then the exact same name underneath it. So in your case, you'll see the _ MSDCS widget LLC.internal, and that shows that it's an Active Directory domain zone. And underneath that, you'll see the actual zone itself. Scavenging, process of scanning records in each zone and deleting stale records. So you need to enable scavenging in a couple of places. One is on the server by right-clicking on the server icon in DNS, go to Properties, Advanced, and you can click on the Enable Automatic Scavenging of Stale Records. And you want to do that for specific zones. You don't have to do it for all of them. You can do it for some of them if you want. And the parameters set at the zone level override those set at the server level. So if you do these changes at the server level, but you turn them off at the zone level, then the zone will actually have precedence. So this is what it looks like when you go into Enable Scavenging. You see the scavenge stale resource records, what the interval is, refresh interval, etc. So you can go in and change that. You can enable it, disable it, whatever it is you want. I recommend that those stay enabled. So that way, let's say computer A has its IP address change at some point, or server A, either one, then you want to make sure that when that IP address gets changed, as soon as possible, then the old records get deleted and the new record is put in place. So by default, set to 7 days. In a small network, I'd recommend you change that to 1 day. So that way it happens more often. In a larger network where there's a lot of traffic going back and forth, you may want to make it 3 or 4 days, but 7, I believe, is just too old. When using Active Directory integrated zones, you don't need to enable scavenging on every DNS server. And that's because of dynamic DNS, which we talked about in our previous module. So that happens automatically. Stub zones. We talked a little bit about stub zones in Module 2, and they're a special type of zone that only has a start of authority record. So reasons for using stub zones, well, you got maintenance of zone delegation information, I should say, in lieu of conditional forwarders. So if you're not using conditional forwarders, then you can use a stub zone. It is very quick, but only over a fast connection between locations. And it gives you distribution of zone information. So all of the information, but without the actual host records themselves being cached locally. All that stuff is done across the network every time a request is made. Zone replication, that's when you transfer zone, the transfer of zone changes from one DNS server to another. So for a standard zone, it's called a zone transfer. Active Directory integrated zones have the following advantage over a standard zone. Well, you have automatic zone replication, it just happens automatically. Multi-master replication and updates. So that means more than one server has authority when you have Active Directory integrated zones when you're doing zone transfers. You get secure updates, so there's an encrypted stream that happens automatically. Use permissions to restrict users who can modify the zone. So by default, only administrators are going to be able to make any changes. And the replication is very efficient. Whereas in a standard zone, you're not going to get all that. You have to set that up manually, and it's not going to be quite as easy to do as the Active Directory one, which is set up for you. Replication scope options. You've got several different options that you get when you go to set up replication. To all DNS servers is one option. To all DNS servers on domain controllers in this domain is another option. The first one is for the entire forest. Second one is for the domain. And then to all domain controllers in this domain if you have older servers such as Windows 2000, which most companies don't have anymore, but you never know. To all domain controllers specified in the scope of this directory partition. So you could also just manually assign who gets those by adding them to the partition itself. So this is what that box looks like when you go to set up zone replication. And those are the exact options that we just talked about. Controlling replication to specific domain controllers. So instead of having replication go to everybody on some of these standard zones, remember Active Directory replication is going to happen by default, so you don't have to do any with that. But if you have standard zones, non-Active Directory integrated, then you have some options here. So we can control replication to specific domain controllers. And this happens when we have many offices with many domain controllers. You don't necessarily want Active Directory replication for DNS zones going across to every domain controller because it creates a lot of traffic and slows some network connections down. So what you can do is you can say the Active Directory replication will only happen to one server from point A to point B, but then at point B it will replicate to the other domain controllers internally. So that way, instead of a mesh situation of replication, you have specific replication between them. And that's typically called a bridgehead server, where one server is a bridgehead on one end and the other is a bridgehead on the other, and they replicate with all of their internal servers, but across the WAN they just replicate with each other. Dynamic updates can be configured in one of three ways: secure only, non-secure, and secure, or none. And we talked a little bit about this in the previous module, so I won't get too much into detail about that, but this is where you can go to make these changes. So if you right-click on the server in DNS Manager, you go to Properties, the General tab, then here's your ability to do the dynamic updates. And once again, dynamic updates are whenever an IP address changes on a computer, then it will automatically update DNS, and you can choose it in a few different ways. Configuring unknown records. Sometimes we get records where the device is just unknown. It doesn't give us any kind of information. Sometimes it's mobile devices that do this. So a new feature of DNS in Server 2016 supports resource records of an unknown type. It allows you to create these resource records in a format unknown to Windows DNS, but that Windows DNS will return in response to client queries. So you can create these unknown records to a zone by adding add DNS server resource record in PowerShell, using the unknown option. So this isn't something that's going to be used very often, but every once in a while maybe a Linux or a Unix server or some of these tablet type devices may need an unknown record in order to still get DNS resolution. Server 2016 adds a new feature called DNS Policy, and this allows you to manage DNS traffic, filter queries, and load balance your applications based on some different criteria. You've got filters, subnet-based traffic, loads of applications, and split brain DNS. So DNS policies can be applied at the server level or at the zone level. So this is new to Server 2016. So there's two primary types of policies: the query resolution policy, and that of course specifies how DNS queries are handled by the DNS server. Then there's the zone transfer policy, and that specifies whether a zone transfer is even allowed. Sometimes when you go to right-click on a zone and you say transfer from master and it fails, it could be because this zone transfer policy is not turned on. DNS objects you can create and manage using PowerShell commandlets. So there's a lot of PowerShell commandlets for creating DNS policies. You've got the client subnet, the zone scope, and the recursion scope. So zone level policies need to create one or more zone scopes. One use of the DNS policies is to ensure resource records of resource close to the client are returned by the DNS server. So what that means is instead of having a DNS server that's in a completely different location or is far away in the office that you're in, it will pick the closest DNS server. Configuring DNS recursion scopes. So there's some different PowerShell commands that you can do here, and the queries will use recursion and which ones will not. You can decide which ones will use one, which ones will use the other. DNS does not have any built-in security when it first came out, although Windows Server 2016 does have a little bit of security that has been added to it. So you do have some real common types of attacks such as spoofing, DNS cache poisoning, denial of service, domain registration hijacking, and man-in-the-middle attacks. These are all pretty well-known types of attacks, especially if you've taken the Datacom class. So DNS has, in Windows Server 2016, something called DNSSEC, which is DNS System Security Extension. So basically, we just refer to this as DNS security. And it's a lot of different features and protocols that validates a DNS server response, so it doesn't get fooled. And three methods to ensure this are the origin authentication, authenticated denial of service, and data integrity. So these are new. Some of these are new to Windows Server 2016. Also, there's zone signing, and that uses a digital signature to make sure that you're getting a DNS server and the DNS server requests are verified by a valid server in your network. DNSSEC has the following additional resource records. There's DNS key and all the other ones that you see here. Zone signing uses public key cryptography, so you can use public key cryptography either by having a root certificate server on your network, or you could use an actual public server, maybe something at Microsoft Azure as well. And by having that signed zone public key, then you're able to trust where that information is coming from. So, client requests a resource record from a zone secured with DNSSEC. Here are the various different procedures that happen. DNS client sends a query to the local DNS server. DNS server sends a query to the root at the top level. Local DNS server receives a response. Local DNS server sends a query to the authoritative DNS server. And then the authoritative DNS server returns the record requested. So there's all kinds of checks and balances here in our validation of DNS responses in Windows Server 2016. So if you want to configure DNS security, just go to DNS Manager, right-click, click the Sign the Zone to start the zone signing wizard. So there's several different options when you do this. So you can do the customize zone parameters, sign the zone with parameters, or use the default settings to sign the zone. And then we have some additional information. We've got keys that you can use, which is basically just a password, or you could use a certificate as well. So that would give it even more security. Of course, the certificate is definitely going to be more secure than just the password, which can be guessed. DNS socket pool is a pool of port numbers used by a DNS server for DNS queries. And it protects against cache poisoning. So that's when somebody comes in and says, hey, this server is not located at this IP address, it's located at this IP address where I've hacked that server and I can gain control of whatever it is you send to it. So there is that, the socket pool protects against that. And there are commands that you can set up for DNS to set up this socket pool. DNS cache locking, another security feature, allows you to control whether data in the DNS cache can be overwritten. So if you don't want to allow an attacker to go in and overwrite something, you can just lock that cache information. So they can't poison that cache and redirect people to servers that have been compromised. And let's see, there are some PowerShell commands that go with that if you'd like to take a look at those. Response rate limiting, another new feature in 2016, mitigates a type of denial of service attack called a DNS amplification attack. This is not available in Windows 2012. This is a new thing. So it uses public DNS servers to overwhelm a target, which is what a denial of service does. It overwhelms a target with DNS responses by sending these queries with spoofed IP addresses. So you can go in and you can stop that because it is disabled by default. Now, if things get really slow because of this or queries don't go through, you may have to go in and disable it. So there is your DNS server RRL information. You can just type that command and see whether or not it's turned on and what the response would currently be. And you can go in and you can change, you can tweak those responses so to make it work right for you, so you can leave it enabled. The DNS-based authentication of named entities. So this is another new feature in 2016. Prevents man-in-the-middle attacks. So you can use what's called DANE, uses Transport Layer Security Authentication, which is a secure way of sending this information. There's records that you can add here using PowerShell commands. These are things that you cannot do using the GUI in the DNS Manager. You've got to use PowerShell commands. And of course, it does use a certificate because TLS uses certificates. Managing and monitoring DNS server. You've got delegated administration and performance monitoring tuning. So two different things. One goes ahead and monitors things that are live, and the other does sort of a baseline for you that you can go back and check against. Delegated administration. Members of the domain admins, enterprise admin group have full access to manage the DNS server, but you may decide you want some people to manually have rights without being parts of these groups, which you can certainly do, and you can without actually giving them too broad of administrative rights. So it does give that kind of capability, which is really nice. So Performance Monitor has several DNS-specific counters. So if you want to use Performance Monitor for DNS, you would type MMC for Microsoft Management Console. You could go and add Performance Monitor, and then you could go in and add these counters themselves. Or you can just go directly into Performance Monitor from Server Manager in the Tools menu. You can also monitor CPU and memory usage by DNS, so that way you can tell whether or not DNS is using up too much processor and RAM. Zone level stats provide detailed look at how DNS server is used. So you've got all different kinds of statistics that you can use in PowerShell. You can do zone queries, transfers, and updates to see whether things are running correctly. So for instance, on a zone transfer, if you want to know if the zone transfer has actually occurred, there is a command for that tells you whether or not the transfer is happening. To display a list of all the DNS-related commandlets, you can type this command that you see here. All right, we talked a lot about advanced DNS in this particular module, covered a lot of ground, and after this you are certainly welcome to go into the lab, and if you get stuck at any point, you can click on the mini videos that are in there, and they should help you out, and of course you've got all different kinds of help available through emails and phone calls. So go ahead and get started on your lab, and then we'll see you again in Module 4.